I'm going to explain shortest job for CPU scheduling algorithm. Its short form is SJF. These are the some points of shortest job for CPU scheduling algorithm. So it can be non-preemptive or preemptive, and it is best approach to minimize waiting time. It is easy to implement in batch system where required time is known in advance. Difficult to implement in interactive system where required time CPU time is not known. And fifth is the processor should know in advance how much time process will take. So these are the difference between preemptive scheduling and non-preemptive scheduling. The In preemptive scheduling, the resources are allotted to a process for a limited time, and in non-preemptive, once resources are allocated to a process, the process hold it till it completes its burst time or switches to waiting state. So in preemptive, process can be interrupted in between, but in non-preemptive, it cannot be interrupted. So this is the question. We are going to solve it. So consider the following four processes with the arrival time and length of CPU burst given in milliseconds. So these are four processes P1, P2, P3 and P4. Its arrival time is given and CPU burst time is given. We have to find out the average waiting time for preemptive SJF scheduling algorithm. So let's solve this question. So let's first draw a line. This is 0. Here process P1 arrives at 0. Arrival time is 0. So process P1 arrive and its CPU burst time is 8. So it will start executing. Now at time 1 process P1 is 8 minus 1 7. Now P2 has CPU burst time 4. So since it is shortest job for CPU scheduling algorithm, so and it is preemptive. So P1 is preempted now, and which one is shortest? P2 is shortest. So P2 is P2 will start executing. So now at 2, P1 is 7, P2 is 4 minus 1, that is 3. Now P3 arrives at 2, so its CPU burst time is 9. Now which is the shortest one? P2 is still shortest, so P2 will still executing. So now at 3, P1 is 7, P2 is 3 minus 1 2, and P3 is not executed, so P3 is 9. Now P4 is arrived at 3, so it is 5. Now which one is shortest? P2 is still shortest, so P2 is executing. It is executing up to 5, means 3 plus 3 plus 2 5. So at 5 P1 is 7, now P2 is 0, P3 is 9, P4 is 5. So which is shortest among these three? P4. So next P4 will execute, it will execute up to 10 because it has CPU burst time 5. So now P1 is 7, P2 gone, P3 is 9 and P4 is 0 now. Now which is shortest among these two? P1. So P1 will execute. So P1 is execute. So P1, so it is 17. 10 plus 7, 17. So P1 is 0. P3 is 9. Now P3 will execute. So 17 plus 9, it is 26. So now P3 is also 0. So you have to end here. Now we have to find average waiting time. Average waiting time. So for P1, average waiting time is how long P1 have to wait. So P1 arrived at 0 and it has to wait up to 10. So this one. So P1 has to wait up to 10. So 10 minus 1. So 9 milliseconds. Now P2 arrived at 1 and it is continuously executing. So no waiting time for P2. So P2 0 millisecond. Every waiting time for P2 is 0 millisecond. Now P3. Now P3 arrived at 2 and it has to wait. It has to wait up to this. So 17 minus 2, that is 15 milliseconds. Now how much P4 have to wait? So P4 arrived at 5 and P4 arrived at 3. P4 arrived at 3 and it has to wait up to 5. So this much time it has to wait. So 5 minus 3, this is 2 milliseconds. So average waiting time is average waiting time equals to 9 plus 0 plus 15 plus 2 divided by, there are 4 processes, so divided by 4. So it is 17 plus 9, 26. So it is 6.5 millisecond. So this is the average waiting time for the processes in preemptive SJF or shortest job first scheduling algorithm. Thank you for watching the video.